All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is atomic structure, subatomic particles in neutral atoms. So we'll begin with neutral atoms. And so we're going to take a look at a number of isotopes. The first one we'll start with is calcium-40. So they give me that information. So the atom is calcium, and it has a mass number of 40. So mass number is the 40 that is after the calcium. So we've got our first block filled in now. So mass number is 40. Now the atomic number is the number of protons. We can read that right off the periodic table. Calcium is the 20th element, so that's the number of protons. It's also, by definition, the atomic number. So I've got a 20 there and a 20 there. Now the difference between protons and neutrons, or the difference between the atomic number and the mass number, 40 minus 20 is 20. That's the number of neutrons. And the number of electrons for a neutral atom is going to be the same as the number of protons. So that'll be 20 as well. Let's look at this one right here. We've got 26 protons. That's the atomic number. So we've got 26 protons. I'll fill in 26 in here. The mass number they're telling me is 56. The difference between 56 and 26 is the number of neutrons, because mass number is protons and neutrons. Protons is 26, so 56 minus 26, 30. And I've got my block there. Now remember that this is a neutral atom. If I've got 26 protons and I've got 26 electrons, protons have a positive 1 charge, electrons have a negative 1 charge. The mass number we've been told again was 56. And when we write the name, remember it's iron. That's the 26th atom. So iron-56 would be the name of our isotope. So there we go. Next is this. We have in this next one we have 8 protons. That means the atomic number must be 8. And when we look at the periodic table, we see that oxygen is the 8th element. They're telling me the number of neutrons is 10. 8 plus 10, 18. So that must be the mass number. The mass number is protons plus neutrons. If it's a neutral atom, and it is, then we have 8. If we have 8 protons, we've also got 8 electrons. Now, we've got oxygen then. We want to write the nuclear symbol. It's oxygen because it has 8 protons. We have a subscript of 8 and a superscript of 18. So we'll place that right there. The name of it is oxygen. We'll write that out, dash, and then the mass number is 18. The next one is the symbol for gold is AU, so that must be gold, and it's 197. We'll write that name in, gold-197. That's the mass number. So 197 is the mass number, and we'll fill that block in right there. Remember that if it is gold, then it is the 79th element. So 79 would be the atomic number, and that is also the number of protons, so I'll fill that one in right there. Remember that the difference between the number of protons and the mass number, or the mass number minus the protons, is the number of neutrons. So 197 minus 79 is 118. I'll fill that one in there. And if it's a neutral atom, and this one is, then we've got the same number of protons as neutrons. If we've got 79 protons, we also have 79 neutrons, and I'm done with this first block. Let's go to the second one now. This is subatomic particles in ions. So in this case, we've got not neutral elements, but we've got ions. So let's take a look. They're telling me that I've got chlorine, but it has a charge of -1. Remember, if they don't write the 1, it's still a charge of -1. They're telling me that there are 18 neutrons. So what can I surmise from that? Well, chlorine is the 17th element. It doesn't matter that it's an ion, it's still the 17th element, so the atomic number must be 17. That's also the number of protons. Remember that protons define the element. The mass number is the number of neutrons plus the number of protons. In this case, 18 plus 17, 35, just like that. This is not a neutral element, so we don't expect for the atomic number or the number of protons to be the same as the number of electrons. We've got a charge of -1. Now remember that electrons have one additional negative charge than do, or that negatively charged ions have one additional electron over protons. So if I've got 17 protons, I must have 18 electrons to give it that charge of -1. Let's look at this one. They're telling me it's silver. That means that the atomic number is 47. I find that from the periodic table. The atomic number is 47. They're telling me that the mass number is 107. So remember that the mass number minus the atomic number is the number of protons, which is 47. I could have also simply copied from here, atomic number 47, number of protons 47. The number of neutrons is equal to 107, which is the mass number, minus the number of protons, 47, that gives me 60, so I'll put a 60 right there. Now, remember that this is silver, so I've got 47 protons. I'll write Ag, that's a symbol for silver. It's got a +1 charge. Notice I've got one more proton, 47 versus 46, one more proton than electron. So it's Ag plus. I could have written Ag plus 1, but I'll just leave it as Ag plus, just like that. The next one is oxygen. The reason I know that is because of the fact that there are 8 protons, right? 8 protons. So that tells me it's oxygen, but is it an ion? Well, it's in the ion box here, so it must be an ion. How many electrons do I have? I have 2 more electrons than I do protons. I've got 10 electrons, but only 8 electrons. 10 electrons, but only 10 protons. That tells me that there's a charge of -2. So it's oxygen because there are 8 protons, so I put O2 minus. I could have written -2 as well. That would have been fine. The atomic number is the number of protons. It's 8, so I'll put an 8 right there. That fills in that box. We know it's oxygen, so now I'll just write oxygen right there. Next, we have a mass number of 27. I'm being told it's aluminum. Now, aluminum is the 13th element. It's the 13th element, so I'll put a 13 right there. This time, there are 3 more protons than there are electrons. Right? 3 more protons than there are electrons. Now, the atomic number is 13. That means that 13 is the number of protons. And protons plus neutrons is mass number. So, or another way to say that is mass number, which is 27, minus 13 is 14. And so that would be the number of neutrons. Remember, I've got 3 more protons than electrons because the charge is +3. I'm being told that right here. So if that's the case, if I have 13 protons, then I'm going to have only 10 electrons. And that fills that box in there, and it fills that entire area. Let's look at number 9. Average atomic mass. Remember that to determine the average atomic mass, I'm going to need to do a calculation in which I determine a weighted average. Let's take a look at this problem. Number 9 says this. Calculate the average atomic mass for neon if its abundance in nature is 90.5% neon 20, that's one of the isotopes, neon 20, 0.3% neon 21, that's the second isotope, and 9.2% neon 22, there's our third isotope. So how do we approach this problem? What we do is we take a look at each one of the individual isotopes. We've got 90.5%, right? 90.5%. Another way to do this is simply to do all of the percentages. I could have either divided each one of these by 100, or I can just take the whole thing and divide by 100. That'll accomplish the same task. So in this case, I've got 90.5, say divided by 100, 0.3 divided by 100, and 9.2 divided by 100. Again, I could have accomplished the same thing by just moving the decimal place for each of these percent abundances, but it's just easier for me to put a division by 100 right here. Remember that the neon 20 has a mass number of 20, so it's approximately very close to 20 AMU. 21 AMU for the second isotope and 22 AMU for the third isotope. When I multiply these on top together and then divide by the 100, I get 20.18 AMU. That's the average atomic mass for neon, and I'm done with number 9. Let's look at number 10. Calculate the average atomic mass of silver if 13 out of 25 silver atoms are silver 107 and 12 out of the 25 atoms are silver 109. Well, if that is the case, then these are in effect percentages. 13 divided by 25 and 12 divided by 25 are percentages. So what I can do is say 13 times 107 AMU, that's for the first isotope of silver, plus 12 times 109 AMU, that's for the second isotope of silver, divided by the 25 total that we were talking about, that's 13 plus 12, and that will give me the average atomic mass, or the atomic weight, or the atomic mass for silver for the weighted average of the 2 silver atoms. Okay, so that's 107.96 atomic mass units. So we'll put that. Let's take a look at the next one. Reviewing concepts. This is the mass of an atom is contained mainly in its protons and neutrons. That should be protons and neutrons, right? The next one is number 12. It's the identity of an element is determined by the number of its protons. Remember, electrons don't define the element, because if the electrons are not the same as the protons, we have an ion. but it's still an ion of that element, so it would be protons. The next one says isotopes are atoms with the same number of protons and different numbers of neutrons. Same number of protons, different numbers of neutrons, that is an isotope. Number 14 says this: the charge of an atom or ion is determined by the number of electrons. Remember, if we've got one more electron than proton, you've got a negatively charged atom, we call that a cation. If we've got one more, an anion. If we've got one more proton than electron, that's a positively charged atom, we call that a cation. Let's look at number 15. Particle X contains 9 protons, 10 neutrons, and 9 electrons. 9 protons, 10 neutrons, and 9 electrons. Particle Y contains 9 protons, 10 neutrons, and 10 electrons. What is the relationship between particles X and Y? So we're told to look at these options and determine which one. Well, the answer is B. Particle X is an atom. Notice that in particle X, we've got the same number of protons and electrons, 9 and 9. Particle Y is an ion because it has 9 protons and 10 electrons. In fact, to be more specific, it's negatively charged, so B would be the correct answer. Why? Briefly explain your answer to question number 15. Well, the same number of protons is the same element, and the same number of neutrons is the same isotope. So a different number of electrons equal different charge. X is a neutral atom, and Y is a negative charged ion. All right, that'll do it for this one. I'll see you on the next one. Thank you. Bye-bye.